We are given that vectors b and c are non-collinear, which implies that the cross product of vectors b and c is perpendicular to the plane containing vectors b and c. This implies that vectors b, c, and b cross c are non-coplanar. And therefore, any vector A can be expressed as a linear combination of these three vectors. Therefore, we can let vector A is equal to x times vector b plus y times vector c plus z times vector b cross c, where x, y, and z are projections of vector A along vectors b, c, and b cross c respectively. Therefore, x is equal to A dot, the unit vector along vector b, which is vector b divided by the absolute value of vector b, which is equal to A dot b, because b is given to be a unit vector. Similarly, y is equal to A dot, unit vector along vector c, which is vector c divided by the absolute value of vector c, which is equal to A dot c, because vector c is given to be a unit vector. And finally, z is equal to A dot, the unit vector along vector b cross c, which is equal to b cross c, divided by the absolute value of vector b cross c. Substituting these values of x, y, and z, we get A is equal to A dot b times vector b plus A dot c times vector c plus A dot b cross c divided by the absolute value of b cross c times vector b cross c. Therefore, the given vector in the problem statement, which is equal to the right hand side of the above equation, is equal to vector A, which is the required answer.